Okay, this is Physics 201, the force table experiment, Lab 8. So we have this setup here. We have these 3 pulleys, and we have this string with these hooks on it. So what we did is we set this to 3 different angles, non-symmetric, non-zero component angles, and I added mass to each one until this string balanced out over the center again. That brings us back to our equilibrium position. So we're going to be measuring the angles and the force on each of these strings to get our vectors. So the force on these strings is equal to the weight of this in newtons. So I have provided you with the mass in grams, so you can convert that to kilograms times 9.81 meters per second squared to get the weight in newtons, which is equal to the force in the string, ignoring the pulley, of course. So the angles, we're going to use, this is our y-axis and this is our x-axis. And we want to measure with respect to the x-axis. So for example, this mark would be our positive x-axis. So that would be 10, 20, 30, 40. 40 degrees for this case. I think this is for the second data table that I've provided. Okay? And for example, this case here would be 10, 20, 30, 40, 50, 60, 70, 80 degrees for the second one. And the third one would be 10, 20, 30, 40, 50, 60, 70. Okay? So as on this diagram, what I was counting was the angle with respect to the x-axis. And this force is going to be our weight on the hook, same as our string tension, and we're going to calculate the components, F's, the y component and the x component. So we can use our basic trig functions. Sine is opposite over hypotenuse, so our y component is the sine of the angle times our value of the weight in newtons. And then we'll find our x component using the cosine function. Okay, so if you look at your data table, you will be able to collect the components for each of your three vectors, your 3 force vectors from each of your strings, and you will sum up the x components and the y components. But you'll have to assign the correct plus or minus sign to each component. So for this case, we're in this quadrant here. Our x and y values are both positive. So we would say a positive number for this in our data table and a positive number for this. Now if we're in this quadrant, we have a positive x, negative y. And this one we have a negative x and negative y. So for this value that's on your data table, again this is I'm referring to the second data table here, we would have whatever values you calculate for your components of the force, or both, you'll have to put a negative sign in front of each of those values since we're in this quadrant. Now for this one, we would have our x component would be negative, but our y component would be positive. So you have to make sure to add those. And then you'll sum up each component, the sum of the y components and the sum of the f components to get the total. And the last thing you're going to do on that, first of all, you'll have to draw a vector diagram. So you'll need a protractor to get the correct angle, and you'll have to use a ruler to get the length of the vector to be proportional to the magnitude. Okay, so our magnitude is going to be, write it like that to represent magnitude. So the higher the magnitude, the longer the length of the vector, and its length should fit some scale based on the units of newtons. Okay. So the last thing we're going to do, we're going to find the net vector. Now this is question, I think, 3 on the pre-lab. So you'll have to think of a right triangle in this. So once you have the answer to question 3 on the pre-lab, this should be a very straightforward calculation. Just think of the basics of a right triangle. How do you find the net vector based on each component? Okay. So you'll have 2 data tables that I'm providing. So you'll have 2 vector diagrams, kind of somewhat similar to this, but you just need to draw the vectors themselves, not necessarily the components. And you'll answer the 2 questions at the end. So your results will be the sum of the forces for each component and the net vector. Alright, so that should be about it for this particular experiment, and the data should be posted. Alright, thank you.